folks, welcome to video lesson 5-2, our second lesson on trigonometric identities. This video is going to be just, for the most part, a lot of examples. Okay, let's just quickly say what trig identities are when we talk about an identity equation. If I solve this first equation for x and this second equation for x, something weird is going to happen in one of them. So go ahead, take a quick second here and solve both of those for x. Okay, if you solve the first one, you do get x is equal to 11. We quite simply do some algebra 1 or some pre-algebra there. Gets x is 11. That is what we call a conditional equation. It is true when x is equal to 11 and 11 only. Okay, the second equation, weird stuff happens, and you remember doing this in algebra 1. Our x's both disappear where we get something that looks the same on both sides. In this case, we get 3x plus 1 is equal to 3x plus 1. This is what we call an identity equation because x can be anything, any real number. The solution to this is any real number works. And so basically we just verified that these two things are equal because we have the same thing on both sides. When we're verifying trigonometric identities, what we're going to be doing is we're going to be getting the same thing on both sides. This is in your notes, but this is basically a list of tips. It's not a recipe, it's not a formula. There is no one way to solve and verify identities. You just got to hunt, peck, scratch, and choose. See what happens, see what you get. I love this. Be like a chicken. Okay, and here are just some of the tips. I would definitely work on the one side of the equation that's the more complicated side. Make the complicated side look like the simpler side. We're also looking to factor. We're looking to add fractions. We're looking to square a binomial and creating monomial denominators. Okay. We're looking to use conjugates, and you know what conjugates are. The conjugate of a plus b, the conjugate of a plus b is a minus b. And the conjugates are what you multiply to get differences of squares, right? Really look for the Pythagorean identities. Those are huge. And if you got some yucky functions like, the secants and the cosecants and tangents, write them in cosines and sines, and often you get some good cancellation to take place. Let's try a couple. Okay. So we want to verify that these two sides are equal. I'm looking right here, and I'm seeing I got cosine squareds on both sides, and I have one sine squared right here. I know from the Pythagorean identities that sine squared is also equal to 1 minus cos squared. So I'm going to rewrite this now as cos squared minus sine squared, which is 1 minus cos squared. And that I got to try to make equal 2 cos squared minus 1. Well, I'm going to distribute my neg. So I have cos squared minus 1 plus cos squared is equal to 2 cos squared minus 1. You don't need to keep rewriting to one side if you're only working on the left. But now cos squared plus cos squared is 2 cos squared minus 1 equals, hey, check. I love that step. Okay, looking at the second one here, I see some negative theta, so I'm already thinking about my odd and even identities. I know here in blue, the blue ones are going to be my odd ones. I know that cosecant is odd. I also know that cotan is odd. However, cosine, of course, is even. Okay? In the odd identities, the cosine of theta is going to be the opposite of cosine or cosecant negative theta. So in the odd identities, I need to change my signs. So I'm going to rewrite this as 1. I'm going to change that plus sign to a minus sign. Cosecant theta over cosine theta, of course, is even. So cosine neg theta is equal to cosine pos theta. And now this is, lastly, an odd one, so I'm going to change that sign to minus cotan theta. And that I want to equal secant theta. I'm going to write everything in terms of sine and cosine, and let's see what happens if I do that. I'm going to write up top. So up top, I'm going to write, let me change colors, 1 minus 1 over sine, and I can get rid of my theta since they're all the same now, over cosine minus cosine over sine is equal to 1 over cosine. Huh. I think now I want to try to get a common denominator. Actually, I could. I see something else, but I'm gonna do it the easy way. I'm gonna factor the cosine out of the denominator of this fraction. So do we see if I factor the cosine out, I'm gonna be left with I'm gonna rewrite the top here: 1 minus 1 over sine over. I'm gonna pull the cosine out, so I get cosine times 1, right? That's my 1, minus, pull the cosine out, I get 1 over sine equals 1 over cosine. Now we see, both top and bottom, I have 1 minus 1 over sine as a factor, so those are going to cancel, and I have 1 over cosine on the left side, 1 over cosine on the right side. Hey, 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 check. And now I will also do this one in class a different way so that you can see it a different way. Okay, there's a bunch of ways to do this one, but I do see a radical. I'm not big on working with radicals, so I'm just going to start by squaring both sides. Now, this is not going to be the quickest way to do this, but this is the way that I would choose to do this. And we can do this a different way in class if you guys would like. But I'm going to square both sides of this right now. So I'm going to get on the, oops, I need a pen. On the right side, 1 minus cos up top, and on the bottom I got 1 plus cos. Do we see that on the left-hand side there? I think I said right, I meant on the left. And I'm going to square the other side, so do we agree I have 1 minus cos squared over sine squared. Okay, now, what I'm going to do is I'm going to work on, even though the right side is more complicated, I'm going to work on the left side and make my left side look like the right side. And I'm going to do that by multiplying by the conjugate of 1 plus cos, both top and bottom. And you'll see why I'm going to do that. So I'm going to take 1 minus cos over 1 plus cos and multiply by 1 minus cos over 1 minus cos. And that still equals now 1 minus cos squared over sine squared. Okay? Up top now, do we see that I'm going to get, on the left-hand side here, 1 minus cos squared. Hey, hey, that looks like the top on the right side. I like that. This is still over sine squared. And now on the bottom, I have 1 minus cosine squared using my difference of squares, and those are conjugates. 1 minus cos squared, we know from our Pythagorean identities, can be rewritten as sine squared. So what I have here is I have 1 minus cos squared over sine squared is equal to 1 minus cos squared over sine squared. Hey, 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 check. Let's do one more. And this one, we're looking to factor. We do see up top I have a sum of cubes. I'm hoping you remember your factoring for a sum of cubes. If I factor sine cubed plus cosine cubed, this is going to be sine plus cosine times sine squared plus sine cosine. I'm sorry, I take that back. Minus, get my eraser, minus, okay, sine cosine plus cosine squared, okay, and all that is over sine plus cos and this is equal to, still, 1 minus sine cos. Okay? Sine plus cosine, these cancel. Hey, hey, gotta like that. Let me change color so we can see it. Do it again. Hey, hey, gotta like that. Up top now, I got sine squared plus a cosine squared. Well, hey, hey, that's our Pythagorean identity. Sine squared plus 1 plus cosine squared is 1. I'm still left with minus sine cos. And that equals 1 minus sine times cos. Hey, 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 they look like they're the same to me on both sides. Check. Okay, we'll see you tomorrow.